Extension cords in industrial settings may be out of compliance with the National Electrical Code, or NEC, the National Fire Protection Association, or NFPA, and the Occupational Safety and Health Administration, or OSHA, for a number of reasons. Firstly, the type of cord matters. NEC, NFPA, and OSHA require the use of durable, hard-usage extension cords for industrial applications. Standard 12.2 SGO cords are not designed for heavy-duty industrial use and may be prone to damage or failure in certain environments. Secondly, the length and current rating are important factors. Long extension cords increase the resistance of the circuit, which can lead to voltage drops and overheating. The current rating of the cord must be sufficient for the equipment it powers. Using a cord with a lower current rating can cause the cord to overheat. Thirdly, grounding is essential. Grounding is essential for protecting against electrical shocks. Extension cords must have a proper grounding connection to ensure that excess current is safely dissipated. Cord caps with 12.2 SGO may not provide adequate grounding protection. Fourthly, environmental conditions matter. Extension cords must be rated for the environmental conditions in which they are used. For example, cords used in wet or hazardous areas require special protection. Fifthly, regular inspection and maintenance of extension cords is crucial to ensure their safety. This includes checking for damaged, frayed wires, and proper grounding. Instead of using extension cords, consider the following alternatives. 1. Install additional permanent outlets near the equipment. 2. Use retractable cord reels or cable management systems to keep cords organized and protected. 3. Explore wire-free solutions such as battery-powered tools or wireless communication systems. When selecting extension cords for industrial use, several factors must be considered to ensure compliance with safety standards and prevent electrical hazards. Firstly, cord type and construction are crucial. Heavy-duty extension cords designed for industrial use are typically constructed with thicker insulation and durable outer jackets to withstand abrasion, chemicals, moisture, and extreme temperatures. Look for cords labeled as hard service, extra hard service, or similar designations indicating their suitability for demanding environment. Secondly, wire gauge and ampacity must be appropriate. The wire gauge, or American wire gauge AWG, of the extension cord determines its current carrying capacity, or ampacity. Choose a cord with a wire gauge that can safely handle the maximum current draw of the connected equipment. Using a cord with an insufficient wire gauge can lead to overheating, voltage drops, and potential fire hazards. Refer to the equipment's nameplate or manufacturer's specifications to determine its current requirements. Thirdly, grounding and polarity must be maintained. Ensure that the extension cord has a proper grounding conductor and that the plug and receptacle are correctly polarized. Grounding provides a path for fault current to flow back to the source, reducing the risk of electric shock. Proper polarity ensures that the hot, neutral, and ground wires are connected correctly, preventing equipment malfunction and electrical hazards. Fourthly, cord length should be minimized. Avoid using excessively long extension cords, as they can increase resistance and voltage drop, reducing the efficiency of the connected equipment and potentially causing overheating. If a longer cord is necessary, choose a heavier gauge cord to compensate for the increased length. Fifthly, environmental suitability must be considered. Select extension cords that are rated for the specific environmental conditions in which they will be used, such as wet, damp, or hazardous locations. Look for cords with appropriate insulation and sealing to protect against moisture, chemicals, and other contaminants. Sixthly, strain relief in connectors must be robust. Ensure that the extension cord has adequate strain relief at both the plug and receptacle ends to prevent damage to the conductors and connections. Use high-quality connectors that are designed for frequent use and can withstand mechanical stress and vibration. Seventhly, regular inspection and maintenance should be performed. Inspect extension cords regularly for signs of damage such as cuts, abrasions, or exposed wires. Replace damaged cords immediately to prevent electrical hazards. Keep cords clean and free from dirt, grease, and other contaminants. Eighthly, proper storage is important. When not in use, store extension cords properly to prevent damage and prolong their lifespan. Coil cords neatly and hang them on hooks or store them in a dry, clean location. Avoid kinking or bending cords excessively, as this can damage the conductors and insulation. Ninthly, compliance with safety standards must be ensured. Ensure that the extension cords used in industrial settings comply with relevant safety standards and regulations, such as those established by the National Electrical Code, or NEC, the Occupational Safety and Health Administration, or OSHA, and other applicable organizations. Look for codes that are listed or certified by a recognized testing laboratory, such as Underwriters Laboratories, or ALL, or Electrical Testing Laboratories, or ETL. Tenthly, training and awareness are essential. Provide training to employees on the proper use, inspection, and maintenance of extension cords. Raise awareness of the potential hazards associated with extension cords and encourage employees to report any safety concerns or issues. By following these guidelines, you can ensure that extension cords are used safely and effectively in industrial settings, reducing the risk of electrical hazards and promoting a safe working environment. The National Electrical Code, or NEC, contains specific requirements for the use of flexible cords and extension cords in various applications. Firstly, NEC Article 400 covers the general requirements for flexible cords, including allowable uses, ampacity, and construction specifications. This article provides guidance on selecting the appropriate type of flexible cord for a given application based on factors such as voltage, current, temperature, and environmental conditions. Secondly, NEC Section 400.8 lists the permitted and prohibited uses of flexible cords. In general, flexible cords are permitted for connecting portable appliances, equipment, and fixtures to a power source. However, they are prohibited from being used as a substitute for fixed wiring, running through walls, ceilings, or floors, or being concealed behind building structures. Thirdly, NEC Section 400.24 specifies the ampacity of flexible cords based on their conductor size and insulation type. The ampacity of a flexible cord must be sufficient to carry the maximum current draw of the connected equipment without exceeding the cord's temperature rating. Using a cord with an insufficient ampacity can lead to overheating, voltage drop, and potential fire hazards. Fourthly, NEC Section 590.4 addresses the use of flexible cords and cables for temporary power in construction, demolition, and similar work sites. This section requires that flexible cords and cables used for temporary power be of the heavy-duty type and be protected from physical damage. Fifthly, NEC Section 590.6 specifies the requirements for ground fault circuit interrupter, or GFCI, protection for temporary wiring systems, including extension cords. GFCI protection is required for all 125-volt, 15-amp and 20-amp receptacles used for temporary power to protect workers from electric shock hazards. Sixthly, NEC Article 520 covers the requirements for theaters, motion picture and television studios, and similar locations. This article includes specific provisions for the use of flexible cords and cables in these environments, including requirements for flame retardant construction and proper support and strain relief. Seventhly, NEC Article 625 addresses the requirements for electric vehicle charging systems, including the use of flexible cords and cables for connecting electric vehicles to charging stations. This article specifies the types of flexible cords and cables that are permitted for use in electric vehicle charging applications, as well as requirements for overcurrent protection and grounding. Eighthly, NEC Article 647 covers the requirements for sensitive electronic equipment power systems, or SEPs. This article includes provisions for the use of flexible cords and cables in SEPs applications, including requirements for shielding, grounding, and isolation to minimize electrical noise and interference. Ninthly, NEC Article 670 addresses the requirements for industrial machinery, including the use of flexible cords and cables for connecting machine tools and equipment to a power source. This article specifies the types of flexible cords and cables that are permitted for use in industrial machinery applications, as well as requirements for strain relief and protection from physical damage. 10thly, NEC Article 690 covers the requirements for solar photovoltaic or PV systems, including the use of flexible cords and cables for connecting PV modules and inverters. This article specifies the types of flexible cords and cables that are permitted for use in PV systems, as well as requirements for UV resistance, weather resistance, and proper labeling. It is important to consult the latest edition of the National Electrical Code, or NEC, and any applicable local codes and regulations to ensure compliance with all relevant requirements for the use of flexible cords and extension cords in specific applications. Additionally, it is recommended to consult with a qualified electrical contractor or engineer for guidance on selecting and installing flexible cords and extension cords in accordance with the NEC and other applicable standards. Alternative solutions to using extension cords in industrial settings can improve safety, efficiency, and reliability. Firstly, installing additional permanent outlets can reduce the need for extension cords and provide a more convenient and reliable power source for equipment and tools. Permanent outlets can be strategically located throughout the workspace to minimize the distance between the power source and the point of use, reducing the risk of tripping hazards and electrical shock. Secondly, using retractable cord reels can keep cords organized and off the floor, reducing the risk of tripping hazards and damage to the cords. Retractable cord reels automatically retract the cord when not in use, keeping it neatly stored and protected from abrasion and wear. Thirdly, implementing cable management systems can help organize and protect cords and cables, preventing them from becoming tangled or damaged. Cable management systems can include cable trays, conduits, and other devices that route and support cords and cables, keeping them off the floor and out of the way. Fourthly, utilizing wireless power solutions can eliminate the need for cords altogether, providing a more flexible and convenient power source for portable equipment and tools. Wireless power solutions use electromagnetic fields to transmit power from a transmitter to a receiver, allowing devices to be powered without the need for a physical connection. Fifthly, employing battery-powered tools and equipment can reduce the reliance on extension cords and provide greater mobility and flexibility for workers. Battery-powered tools and equipment are becoming increasingly powerful and versatile, making them a viable alternative to corded tools in many applications. Sixthly, installing overhead busway systems can provide a flexible and expandable power distribution system for industrial facilities. Overhead busway systems consist of a series of interconnected busbars that are suspended from the ceiling, providing a convenient and accessible power source for equipment and tools. Seventhly, using power distribution units, or PDUs, can provide a centralized power source for multiple devices, reducing the need for multiple extension cords and power strips. PDU can be mounted on walls, racks, or other surfaces, providing a convenient and organized power distribution solution. Eighthly, implementing zone power distribution systems can divide the workspace into zones, each with its own dedicated power source. Zone power distribution systems can improve safety and efficiency by reducing the risk of overloading circuits and minimizing the need for long extension cords. Ninthly, utilizing mobile power carts can provide a portable power source for equipment and tools, allowing workers to move around the workspace without being tethered to a fixed power outlet. Mobile power carts can be equipped with multiple outlets, surge protection, and other features to provide a convenient and reliable power source. Tenthly, implementing a combination of these alternative solutions can provide a comprehensive approach to power distribution in industrial settings. By combining permanent outlets, retractable cord reels, cable management systems, wireless power solutions, and other technologies, it is possible to create a safer, more efficient, and more reliable power distribution system that minimizes the need for extension cords and improves overall productivity. When selecting alternative solutions to extension cords, it is important to consider factors such as the size and layout of the workspace, the type of equipment and tools being used, the power requirements of the equipment, and the budget for implementing the solutions. Additionally, It is important to consult with a qualified electrical contractor or engineer to ensure that the solutions are installed in accordance with all applicable codes and regulations. Implementing alternative solutions to extension cords can provide numerous benefits, including improved safety, increased efficiency, reduced downtime, and lower operating costs. By investing in these solutions, industrial facilities can create a safer and more productive work environment for their employees.